Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. This video is an addendum to the 12 video Adventures with Python series, in which we learned Python programming from installation through object-oriented design by building a text adventure game. I'll link the playlist here. In this video, I'm going to add actions to items in the game. We're not learning any new Python here, but we will learn one way to implement object state changes, which will allow you to enhance your program so it becomes a game you can play rather than just a place to explore. Let's get started. Let's begin with the idea of state. We can think of state as the values in variables of interest, and a state transition is a change in those values that is triggered by an action. Let's imagine a door in our dungeon. The door could have two states, locked and unlocked. Its start state is locked. It begins in the locked state. And associated with the locked state is some descriptive text, such as the door is locked. In the unlocked state, the door might have some descriptive text, such as the door is ajar. Just as an example. And to get from the locked to unlocked state, the action might be unlock. In a game, we might use an item such as a key, and if it's the right key, the door changes state. We want to implement this state idea using a general mechanism so we can easily add items with actions to our system by making changes to the game data stored in the JSON file, and not by changing the code. Think of the game as an engine that will run with any dungeon we can build in the JSON. To illustrate, I've added state to my exits. You can apply this same idea to locations and items. In other words, locations can have states such as dark, flooded, crawling with monsters, whatever you can think up. And items can have states such as cooked, raw, corked, locked, again, whatever you can think up. But in this example, I'm going to only have exits with state, and the only states are going to be locked and blocked. Hopefully it will be clear how to scale this. To review, we have location objects representing each location in the dungeon, and the locations each have an inventory. The game keeps track of a player inventory and the current location. The inventories maintain a dictionary of item objects. I've made one change to the game from the last version. I've decided that rather than have locations have direct references to other locations, I gave the game a lookup table of location name, location object pairs, and the location objects only have the other objects' names, just like in the JSON. So in the exits dictionary, N church, rather than N and then a reference to the church location. I did this because it made reading in the JSON easier. Now it only needs to be read in one pass. And because to add state to the exits, I created an exit class, and it's the exit now that's going to reference the location, and that made reading in even more complicated. So I decided to simplify it, and I'm much happier with this design. Let's look at the exit class. This file is exits.py, and you can see the class diagram for exit to the right. In our location object, we previously had an exits dictionary where the key was a string indicating direction, such as north, south, east, or west, and then the value was the location the player would go if they took that exit. Now the exits dictionary is a string key indicating direction, such as north, south, east, west, and then an exit object. The exit object has a name, a description, and the location the player will end up if they take the exit. I'm showing you a sample JSON so you can see examples of values for these fields. So name, for example, should be something unique. I've decided to name my exits by where they lead from and to, so for example, cloister to church door. You'll see why that's important in a moment. The location you get to from the cloister to church door is the church. That would be stored in the location field. And this door has a description, a sturdy-looking door with a diamond-shaped stained glass window. So far, none of that is part of the state of the exit. That's all static and doesn't change. The changeable part of the exit, constituting its state, is the state field. This is just a list of strings. I initially did have a list of enumerated types to limit what could be stored as state, but the advantage to strings, besides that they're easier to read and write to the JSON, is that we can add state descriptors in the JSON and the engine will still work. Right now my only state descriptors are locked and blocked, but we could add smashed or jammed or boarded up or whatever we want, and the game will still work. We're keeping the engine as separate from the dungeon as possible. Now, along with the state field, there is a dysfunctional states field. Maybe we want to give exits some states in which they're still functional, For example, maybe there's a special light that reveals writing on the door. That will change the description, but it won't prevent the door from working. So the dysfunctional states list is those states that make the exit dysfunctional, so the player can't use it. For this example, both locked and blocked mean the player cannot go through the exit. They'll have to solve those problems by using an item. The state descriptions dict is a dictionary of state as key and description as value pairs. When the exit is in a particular state or states, we'll add the appropriate description pieces to the description of the exit. Those could be the empty string if we don't want to add anything, but if we do want to add something, we can. And finally, the state change is keyed on action. So for example, unlock and unblock, these are the actions the items can take. And then the state that will get removed from the exit states list if the action happens, and a string if it's successful, and a string if it fails. So for unlock, it acts if the exit is locked, that's the state. And if successful, the string is, there is a click, and the door swings open. But if unsuccessful, it means the exit wasn't in that state, and so the fail string is, the door isn't locked. And for methods, we have some accessors, getName, getDescription, getLocation, and the serialization methods to JSON and from JSON. The getDescription method will return the exit's description, and then add on any bits of description related to state. Then there's useItem. This will potentially transform the exit state if appropriate. So if it's locked, then unlock will take locked out of its state and return there is a click and the door swings open. Right now, isImpassable is only used internally in getLocation. The exit will not return the location string if it's in a dysfunctional state. Maybe I should have called that impassable and not dysfunctional, but I'm not going to edit my JSON encode now. Now, item, you'll recall, did almost nothing before, but it actually doesn't have much more to it now. An item has a name, a description, an action, and an object. And so those fields are serialized, but then the only thing it does that's new is it has a use method that returns its action and object. The action is the action it can enact, such as unlock. Remember that from the exit JSON? An action is an action that can transform an exit state. And the object means the object of its action. That's the unique name of an exit. I didn't call it exit because we may want items to be able to act on locations and other items, as I said. So that object could eventually be a location name or another item name. As long as it's unique, and the action is one that can transform the exit, location, or item, then this will work the same way. Looking at the top of my JSON, you can see it's gotten more complicated in the exits. So whereas before it said, for the cloister, n:church, now it's n and then a whole dictionary of exit information. And this is the only exit I've made interesting. All the others have simply a name and location, and the rest are empty strings or lists or dicts. I did decide to let each one have dysfunctional states of locked and blocked, only because if I did make them more interesting in the future, I wouldn't want to forget to do that. But right now it's irrelevant. They aren't locked or blocked and can't become locked or blocked. And for the items, for my original items, I've added empty string, actions, and objects. But I've added some new items. A key that can unlock nothing, and a latch key that can unlock cloister to church door, and a shovel that can unblock cloister to church door. So you can see that the player must find these items and use them both in the cloister to unlock and unblock the north exit before they can pass through it. I will show you that in the game, and then I'll show you how the game engine works. I'll run the game and go east to the library. That's the red herring key. I'll take it. And then north to the storeroom. There's the latch key. I'll take that. Southwest. Now west to the garden, and I'll take the shovel. East, and I'm back in the cloister. Now if I try to go north, the game tells me I can't exit in that direction. I changed this text slightly. Before the game was saying there's no exit in that direction, but that's not always going to be true any longer. Sometimes there will be an impassable exit. I'll try the key. I'll type use key. It says I can't use that here. That's because its object isn't our locked door. I'll use the latch key. Okay, there is a click and the door swings open, but I still can't go north. I'll look. It tells me there's a pile of rubble in front of the door to the north. I'll use the shovel. It tells me I've cleared the rubble, and now I can go north. If I try to use the shovel here, it tells me I can't use that here. Okay, let me quit and change the JSON. I'm going to take blocked out of the dysfunctional states, and I'll repeat playing the game and getting the latch key and unlocking the door. Now I can go through it even though it's blocked, because blocked isn't a dysfunctional state. It's just descriptive. So I could add more functional states and dysfunctional states in the JSON, and the engine will respect what's functional and dysfunctional. And if I add items or change items to transform the states, the engine will allow the transformations. So this engine is a general way to handle functional items in the game. No special cases, no writing logic in the game if you want to make changes, just change your JSON. Let's look at how the engine works now. In command type, I have added a use command. Down in play, in the game loop, in game, I have added elif command.isType, command-type.use, and then response equals self.handleUse command, the same pattern as for other command types. Let's look at handleUse. We first get the object from the command. That will be the name of the item the player wants to use, so use key, for example. If that is none, then we tell the player they must use something in their inventory. That's like if they typed simply examine, take, or drop. We tell them they need to examine something or take something or drop something. It's the same logic. But if they did type something, we'll check if it's in their inventory. If it isn't, this is the same output as for examine. If they try to examine something they don't have, we tell them you don't have a key. But if they do have whatever they're trying to use in their inventory, then we send the getItem message to the player inventory. I believe this is a new method I added, so we could get the item from the inventory using the item name. And then we send the useItem message to the current location and pass in the item. This is also a new method. Let's take a look at how a location handles the useItem message. I am imagining that eventually the location could try to use the item on itself, or on items in its inventory, or on the exits. Remember that the item works on one specific object, so we can try all of those things, and we will only ever find one object it can work on. For now, items only work on exits. So the location sends the use message to the item, which returns the object it can work on and its action. The location then goes through its exits, and if an exit name matches the name of the object the item can operate on, we found the correct object, and we send it the useItem message with the item's action. So for example, we have a latch key. Its object is cloister to church door, and its action is unlock. We send unlock to the exit named cloister to church door, and it will either send back there is a click and the door swings open if the exit is in the locked state, or the door isn't locked if it's not locked. That's the success string and the fail string, respectively. Let's look at that code in exit. Here is useItem. It checks if there's a dictionary entry for the action the item is enacting, such as unlock. If there isn't, we return, you can't use that here. That shouldn't happen if we wrote our JSON correctly, but it's best to check. Then the exit checks if it's actually in the state that is needed for this item to work, so in our case, locked. If it is, then we return the success message, and if it isn't, then we return the fail message. Back in location, if we had never gotten this far at all, we'd just be returning, you can't use that here. Are you up for a sequence diagram? I'll upload this to my GitHub repository with the code. By the way, I haven't fully tested my classes yet. I'm not sure if I'll get them tested before I upload, as it's finals where I am. So I may just comment out the testing code. Feel free to test my classes yourself, and do comment if you find a bug. Now, this sequence diagram has two things that weren't in the others I showed you. So not only do I think this might help you grasp how the objects interact to use an item, but it'll show you how to model a couple of things in sequence diagrams that we haven't seen before. The interaction begins with the player typing use, followed by an item name, and that could be nothing, they could have simply typed use. And the initial interactions with the command object should be familiar. The game asks if this is a use command, and the command responds true, and the game then gets the object of the command because that's relevant for a use command. It answers the question, use what? But I have something here I didn't show before, and that's the game object sending itself a message. Now, I don't think it's important to show this in this diagram because this is really an implementation detail. The game object is sending itself the handleUse message, which is a private message and only exists to simplify the game loop. But sometimes it is important to show a self call. So this is how you do it. Show an arrow from the activation bar of useItemName back to the game object's lifeline labeled with the method name, but layer another activation bar over the original activation bar. So now we're looking at message sends from handleUse. So it's actually from within handleUse that we're sending the getObject message to the command. And then we have an alt box. If there is an item name, and if it's an item in the player's inventory, then we get the item from the player's inventory. Then we send the use item message to the current location with a reference to the item. So note that in object-oriented design, this is another way that an object can send messages to another object if it's passed as a parameter to a method. The current location doesn't know this item. It doesn't have a has-part relationship, not a composition relationship, nor a navigation relationship. But this is a sort of temporary acquaintanceship, where it's sent as a parameter so the current location can interact with it just to implement this specific functionality. So the location sends the use message to the item and gets back the object of the item's behavior and the action. The object of the item's behavior is going to be the name of the object, so the location iterates over the exits to find the exit with that name. Again, if you want to expand this, the location could here check if that is its own name, and then implement the action on itself if appropriate. Or it could check through its own inventory to see if the action is happening to one of its items, and then it could check its exits. So you could easily expand the engine to allow items to operate on locations and other items. Now it may have found an exit with that name, or it may not. So we have an alt. And notice that this alt has a dashed line through it and two guards, one under the alt that says name equals object, and one under the dashed line that says object not found. That's an if-else. If the correct exit is found, the current location sends the use item message to the appropriate exit with the action from the item, and the exit returns a response. Remember, that could be the success message or the fail message. But if the exit wasn't found, I'm showing that the location sets the response to you can't use that here. And then it returns response to game. So this dashed line through an alt with guards under the alt and under the dashed line shows an if-else. Notice I have another one back in game. Suppose the item name wasn't in the player's inventory. That's the long dashed line in this box. I've put another alt here because we return two different messages if there was no item typed versus if the item isn't in the player's inventory. So I show both of those in an alt with two guards and a dashed line. Now, if this level of detail makes the diagram too complicated, in your opinion, you can draw separate diagrams for each path. This is more helpful in building the algorithm, but no matter how you do it, you're showing the messages that are sent, the order of the messages, and which objects are involved in fulfilling the use case. Just drop a comment below if you have questions about this sequence diagram. Let's add a state to an exit in the JSON, and an item that can operate on the state to illustrate how the engine is separate from the data. In the library, I'll add some state to the door to the north, the door to the storage room. I'll add a description. There's a placard hanging on the door, but it's blank. I'm not going to add anything to state descriptions. In state, I'm going to add invisible writing. I'm not going to add that state to dysfunctional states. The door will work just fine. I'm going to add one state in state changes. Reveal will be the action, and the state will be invisible writing. For fail string, I'll write no amount of wiping brings the message back. For success string, I'll write wiping the placard reveals a hidden message, 0 days since last accident. As you ponder the meaning of the message, it vanishes, and no amount of wiping brings it back. So, like unlock and unblock, this is a one-time state change. Invisible writing will be removed from the exit state once the proper item is used, and we won't be able to use it again. Now, let's put a rag in the kitchen that can be used to wipe this placard. I'll add to the kitchen's inventory an item keyed on rag, name rag, action reveal. That's the same action we put in state changes for the exit, description, and oily rag. And for object, we'll need the exact name of the exit, which is library to storeroom door. Now, let's play the game. Go south to the kitchen, grab the rag, go north, try it in the wrong room. You can't use that here. And go east to try it in the library. So in the library, we see there is an exit to the north. There's a placard hanging on the door, but it's blank. Now, I can go north because that invisible writing isn't dysfunctional. So I'll go south again and use rag, and I see the message, but I can't get it back. If I try using the rag again, I get the fail message. No amount of wiping brings the message back. So again, you can add to your engine using this model so you can use items in locations as well as on other items in addition to using them on exits. To practice, as always, I recommend you try rewriting what we've done here from scratch. I recommend playing around with the JSON to get used to adding items with actions and exits they can act on. You can do that just with my JSON and my code. You can build your own entire dungeon. I'd recommend doing it a small piece at a time because it is easy to make a mistake with the JSON. One extra curly brace can take a while to hunt down. But then add actions to locations. follow my model here. Give the location, states, state descriptions, and state change dictionaries, just like I did for the exits. Then, when the location gets the use item message, it can check itself before it checks the exits. As long as the names are all unique, the code won't need to be modified very much. But if the item is going to have an effect on the location, you'll need to write the state change code as we have for exit. I hope you've enjoyed this series. I may add more functionality to this program, or I may use it to show you other object-oriented design patterns or Python features. But for now, I believe I'm going to take a break from Shabby Abby. Drop a comment if there's something specific you'd like to see, and if I can do it in a future video, I will. As always, have fun and keep coding.